hyperbolic plane defined by the metric. Metric क्या है जी बताएं?
ds square.
ds square equal to y to the minus 2
into dx square.
dx square dy square. So that's the metric of hyperbolic plane. We are interested in finding out its equations of geodesics. So हम इसके अंदर ये define करना चाह रहे हैं, देखना चाह रहे हैं कि geodesics क्या है इसकी. So आपको पता है कि need to define first of all क्या चीज़ हम define करते हैं यहाँ पर s define करते हैं, which is the length a to b, and you all know that this is given by the metric square. So this can further be written by as a to b. So I'll put the value of this line element y to the minus 2 dx square plus dy square, and so like roughly by multiplying and dividing with d sigma I can convert this into this y to the minus 2 dx by d sigma squared plus y to the minus 2 dy by d sigma squared d sigma. So what is going to be my Lagrangian L? dx alpha by d sigma x alpha. This should be given by the square root of y to the minus 2 times dx by d sigma squared plus y to the minus 2 dy by d sigma squared. So in short I can write this x sub sigma. So y minus 2 x sub sigma squared plus y to the minus 2 y sub sigma squared. What I need to compute now? I need to compute Lagrangian differential equation. जहाँ से अब variational principle से जहाँ से हम जो है फिर आगे देंगे. So the variational principle के मुताबिक आपके पास ये जो equation of geodesics है that will be given by d to the d by d sigma of partial L by partial of x alpha sigma plus partial L by partial x alpha equal to 0. But for alpha 1, let's choose alpha to be 1. For alpha 1, what is going to be our variable? And how is this Lagrangian reached?
Variable x over.
What?
Variable x over.
So let me say my alpha is 1. In that case I'll get minus d by, so it is invisible, I need to bring this over. Okay, so help me out. What I need to compute now? Tell me. अब क्या compute करना है हमने?
x1
So alpha 1 अगर रखें, so you can say
x1
derivative with respect to sigma of partial L by partial, so it's going to be x sigma plus partial L by just partial x equal to, so this will give me first equation for geodesics. So let's compute this. Here हमारी जो partial L by partial x है, this should be 0 because there is no any x variable inside this L. And then I need to compute the partial derivative of L with respect to x sigma. So this should be 1 over 2 L. I have to compute the derivative of this. So by chain rule, 1 over 2 times what I have to compute?
2x sigma.
2x sigma times y to the minus 2.
Yes.
And which is equal to what? 2 cancelled. So what is going to be the equation?
1 upon x.
1 upon y square times L multiplied by dx by d sigma. Okay? Then we already know that हमारा L जो है वो किसके बराबर होता है?
dx over d sigma.
L किसके बराबर होता है जी?
ds over d sigma.
हाँ ठीक है. So partial L by partial x of sigma is equal to 1 over y squared times 1 over ds by d sigma. So this quantity is coming out of this. So s was equal to So my S was equal to A to B L, so d sigma, and from here you have this fundamental result, basic result is. So I can substitute this L. Then I get dx by d sigma. But on simplification, what will I get? So I'll get 1 over y squared times dx by d s. Then this implies minus d by d sigma of partial L by partial x of sigma equal to minus d by d sigma. So it's not by, it's the derivative with respect to sigma, of course. 1 over y square dx, derivative of x with respect to s. And then you can, play with this from here. So I can also say that my d sigma is L by ds by dl, ds by L. So I can, substitute here, and I'll get d by ds. So it's the 1 over y square. So when I say d by ds, I mean the derivative of the variable with respect to that corresponding variable. So it's going to be minus L times whatever this is. So when you substitute all of these, this computation and this computation into the equation, what will we get? We will achieve this minus L times the derivative of this quantity with respect to s dx by ds plus 0 equal to 0. Then on simplification, I'll achieve what? So you guys will help me out. So we will get d by d s of y to the minus 2 derivative of x with respect to s equal to 0. Then I can apply the chain rule or product rule. So I'll get minus 2y into dy by ds dx by ds plus y to the minus 2 same. So it's d square x by ds square equal to 0. Then finally my first geodesic equation will read as the second derivative of x with respect to s to be 2y by 2y by minus y minus y to the minus 2, and then dy by ds and dx by ds. या आप इसको क्या लिख सकते हैं? So it is going to be 2y cube dy by ds and dx by ds. So this is the first geodesic equation. अब हम इसी तरीके से क्या करेंगे? सेकंड geodesic equation फाइंड करेंगे. So इसको आपने ध्यान में रखना है. लास्ट में हम इससे कुछ और कंप्यूट भी करेंगे. इसमें कोई प्रॉब्लम तो नहीं है?
सर सेकंड भी ऐसे ही आएगी सिर्फ.
हाँ? नो, सेकंड ऐसे नहीं आएगी. सेकंड ऐसे नहीं आएगी. उसमें कुछ टर्म्स और भी आएंगे. जी.
आई थिंक सर जो हम डेरिवेटिव ले रहे हैं ना y -2 का, वो आ जाएगा -2y -3.
Exactly. So we can make mistakes. Yes, you are so right. So then where will be the change? So here I will have -3. So it's going to be 2 over y. Yes. I was also wondering. Now it's fine?
Yes, sir.
Okay, cool. So now we will find out the second geodesic equation.